Morning, this is your Stat Sensei, Mr. Spensei, and this is an exit ticket on hypothesis testing. And we are going to be doing exhaustion. Um, the EPA requires that the mean exhaust emissions for a certain car size to have no more than 145 grams of nitrous oxide per mile. A car manufacturer claims their new process reduces, that's important, the mean level of exhaust emitted for their cars. A simple random sample of 33, there's our sample size. So N is 33, is taken, and the mean level of exhaust for this sample is 1.27. So our X bar is 1.27. The population mean, they told us, was 1.45. It is known the exhaust emissions are skewed right and have a standard deviation of 0.54. So our population and standard deviation is 0.54. This is skewed data. We got to be careful. All right. Um, there are more than 30,000 cars of this model. So there's our population size. So we have a sample size and our population size. Write the null hypothesis and define the parameter, run the test using an alpha level of 0.05 and state the decision and write the conclusion. Do not write the condition. So this is in our note spiral. So we're going to go ahead and we're going to start off by writing our formula. Z equals X bar minus mu, standard deviation of the population divided by the square root of n. We previously said the mean was 100.45. I'm going to put G for grams. Our standard deviation was 0.54 grams of nitrous oxide. Our X bar, we said, was 1.27, and our sample size was 33. All right. So if I'm drawing a picture, please remember confidence intervals are centered on X bar. Hypothesis tests are centered on the mean. And in this case, they said they wanted to reduce. That means it's going to be a less than. So we're circling this symbol. Um, our mean is 1.45. And we ended up with an X bar right here of 1.27. All right, plugging in. Z equals 1.27, the sample mean minus the population mean of 1.45, divided by the population standard deviation, divided by the square root of the sample size, which was 33. By the way, we only have one sample, so this is a one sample z-test. Now, technically, it's a one sample z-test for means, but you tell me it's one sample z-test, I'm going to be very happy with that. All right, the null hypothesis, HO, mu equals. I know it's a mu because that's what we're talking about, and this will always be an equal sign for the null hypothesis. So mu equals 1.45 grams. The alternative, mu 1.45 grams. Everything's the same except for the inequality. Well, they said they wanted it to be less than, so less than would be that. That's all we have to do. The next thing it asks us to do is define the parameter. It's always going to be let mu equal the true population mean. Now what? Well, what did we care about? Exhaust level or nitrous oxide level. I'm going to just say exhaust. Mean amount of exhaust. All right. They said skip the conditions. So we're going to go ahead and run this test. So to do that, I need to go back to my calculator. I'm going to go stat test, and we're looking for z-test. And our mean was 1.45. Our standard deviation in this case is 0.54. Our sample mean was 1.27, and our sample size was 33, and we needed a less than. When we calculate, we end up getting Z, probability Z is less than negative 1.9148. So the probability that Z, and since we have less than there, we're going to write the same thing there. Z is less than negative 1.9185. These inequality and this inequality always need to match, equals 0.0277, unless we're doing a two-sided test. 0.0277. So we're going to write our p-value down here, 0.0277. Our alpha is 0.05. And this is less than. And our decision is to reject the null. So our conclusion, our p value is 0.0277. By the way, I should have made these the same length, because clearly you can see that 277 is less than 500. So always make the decimals the same length. So our p-value is 0.0277, which is less than our alpha. And you can either write the word alpha out or use the symbol alpha equal to 0.05. So our decision, we reject the null. There is sufficient evidence suggests sufficient evidence to suggest what? Well, we're going to have to restate our definition that the true population mean amount of exhaust is, and what did we have here? Less than 1.45 grams. All right, I want to talk about this real quickly. This right there is our alternative hypothesis. Less than 1.45 grams. That's what it is. This right here to suggest the true population mean amount of exhaust. The true population mean amount of exhaust is just our parameter. So this is a restatement of our parameter. All right. Thanks for watching. Hope to see you on the next one.